Hello. Right. Sorry. We are live. I just forgot to connect the phone. Yeah, I just need to change the setting of a few things. Alright, I should be good now. Sorry, I actually turned the phone off, the microphone off. It should work now, right? I think it should be better than the previous time. Anyway, so we start to bring y together and x together. First we move the dx. We have y dy and then x squared minus 7x. The dx on the other side will be dx like that. Now we have y dy and x dx. We can do the separation of variable. That is what we have here. Y with y, x with x. Then we will integrate both sides. Right? And then integral of y will be y squared over 2. And integral of this side will be x cubed over 3 minus 7 x squared over 2. Yes. We need a constant on either side. I'm going to put here. Alright. Next we try to get the y by itself, or the y square first. So I will multiply both sides by 2. So multiply 2 to everything. 2 and 2 cancel here. We have y squared equal to, multiply the 2 on top, we have 2x cubed over 3. And 2 and 2 cancel here. We have minus 7x squared and then 2c. Right. Note that c is an arbitrary constant. 2c is that also a constant. It is still a constant. So I will write y squared equal to 2x cubed over 3 minus 7x squared plus c. And because that's a constant, 2c is just a constant, so I still can just write c. And then you take the square root, and we take a square root on both sides. We have this. That's separable equation. Let me add the title. We're good. We have the title. Right. On the test, we can either stop at the y squared equal to or this form, the equivalent. Bottom line is we try to get away of get out of this integral and try to simplify as much as we can. Right. So that's a separable equation. Left for number 19. On the next one, it is easier, but still requires some trick. There's a trick to that. So most of these problems are kind of different ways. Anyway, so I go to 20 because we need that too. Right. For 20, even though we don't have a question on that yet, but just thing that we need to do. First, move the dx over. So we'll have dy equal to y over x to the 7 dx. And then we will divide y to the other side. And we have that. Alright. And then of course we integrate both sides. So now x on one side and y on one side, those are the condition for separable equation. So we integrate. We know integral of 1 over y, so we're going to just leave it like that. But on that side, where we integrate, it's better to write as a power of -7, because we're going to use the power rule. Right. Integral of 1 over y is ln of y, ln of absolute values of y, and x to the 7 is x to the -6 over -6 plus c. Right. Next we try to get rid of the ln and the absolute values. Right. So let's rewrite that. And x to -6, bring it down, it becomes -6 x to the 6. It's better that way. Still plus a constant c. Right. Next, if we want to get rid of the ln, we need to raise both sides as part of e. Let's use that. E and ln cancel here. We just have absolute values of y. And that for this we use this little property. We have e of a sum or any base for that matter. Let's see, we have the exponents like that. So we can write e to the m and e to the n. So we split this sum and turn that into a product. Next, we'll get rid of absolute values by throwing the plus or minus. So if we want to get out of this, it will be plus or minus on one side. And e to the c. Right. Next, e to the c, I move that in front right after the plus or minus. The minus you can write pretty much the bottom or preferably on the top. Right. Next, all of this, e is a constant, c is a constant, plus or minus is still a constant. Because of that, we just need to write y equal to a constant e to the -1 over 6x to the 6. So that's just a constant. Alright. I'll leave that for a moment while I wait for next question and update this list. This time I put the question in the topics. So we're still in doing the separable equations. Right. Right. Next, I will not do 21, but at least set it up. So again, we need x on one side and y on one side. So we have dy and move the dx over. And dx here. The y squared to the other side. And then we have x on one side and y on one side, and then we can integrate. Right. Next, we're not gonna finish that problem. We go to some other question. Initial variable problem. Now we go to different type. So let me update that list. Right. Change that a little. Initial variable problem is a subtopic of separable equation. We still have the equation, but we just need to find the initial variable problem. So we did either do 22 or 23. Let's take a look at those two. Right. I'm set up 22, but then actually we'll do number 23 instead. So. Right. So just need to set it up on 22. First, we still need preferably x on one side and y on one side. So I move the 2x on that side. And the dx. And then we can integrate. This problem, it is easy because it just integrate dy, which is y. So when we integrate, we have the solution already. And make sure we need to use that condition. Right, I'm not going to do this one. I'll let you finish this problem. Very simple. What we do instead is 23. So we're still under the separable equation though, so that's why I didn't change the color yet. Right. We'll do completely 23. By the way, number 23 here somehow related to what we the problem 21, which we didn't do. And once again, if you have any questions, please post on the chat. Just also, if there's anything happen with the stream, please let me know. I check the stream regularly. I mean the chat regularly. Right. Next, this one is also separable equation. Number 23. So what I do? Move the dx over. And divide by the y square. Right. And then we integrate. So integrate 1 over x integral ln of absolute of x plus c. That part is easy. This I will rewrite as y to the negative 2 dy. It's easier to have as the power for the power rule. Right, power rule, y to the negative 2 plus 1 will be negative 1 over negative 1. Right, now we multiply negative 1 on both sides, and we will have y to the negative 1. If we multiply negative 1 on both sides, that cancels with this. So I better write multiply with negative 1. So I have negative ln of x minus c. Minus c or plus c is still a constant, so it doesn't matter. We just leave it like that. Alright, next, y to the negative 1 is 1 over y. What we do next is, if we can write this over 1, and we're going to flip both sides. So y equal to 1 over negative ln of x minus c. This is 1. Next, we use the initial condition, this condition. Meaning that when x equal to e, y equal to 2. So I'm going to put 2 in for y. And x is e. Right. Now we have 2 equal to 1. ln of e is going to be 1, so we have minus 1 minus c. Next, if we have a fraction, we can cross multiply, and we have negative 2 minus 2c equal to 1. Plus 2 on both sides. Negative 2c is 3. Just plus 2 on both sides. And then divide by negative 2. So c is equal to negative 3 over 2. Which we can use and substitute back in to this c. So y will be equal to, sorry, wrong one, I mean to that c. So y equal to 1 over negative ln of x minus c is minus 3/2. Right, so it will be 1 over ln of absolute value of x, that's negative, plus 3/2. If we want to, we can multiply both sides, I mean top and bottom, by 2 and simplify the problem, but it's quite good enough, because we have y is equal to a function of x, and there's no arbitrary constant c, so that is good. Right, I got a feeling that I need to do 24 as well. That application we haven't done in class, I think. Right, 24, a little long problem, so let's cut that in half. First we start with this differential equation. Right, now we solve for y. To get rid of the derivative, we can integrate both sides, but it's also separable, so move the t, move the dt, and integrate. And then we can integrate. Easily this integral of dy, just y. Now integral of this 6000 is 0.06 t over 0.06 plus c. This part is the integral of e to the 0.06 t. Right. So what we can do, of course, try to divide that 6000 divided by 0.06. So 100,000. And then still have that. Right. Next, we have initial condition where t equal to 0, the population is 100,000. By the way, actually we get to that after these two steps. Right. Right. Next, we're going to use that information when t equal to 0. That equal to 100,000. So the population is 100,000 equal to 100,000 e to the 0.06 t plus c. and that is where t equal to 0. So we should write at t equal to 0, the population is 100,000. So e to 0 power, that is 1, and we just have 100,000 equal to 100,000 plus c. From there we can get c is a constant, 0. Well, we can substitute back in here, and the equation is 6,000. I'm sorry, this is better. 100,000 e 0.006t. The constant is just 0, so we don't need that. And finally, what is the population in 2050? Right. Since we let 1980 be t equal to 0, so in 2050 the time will be equal to 70 years after 1980. So we take at 2050 minus 1980, we have 70 years. And then we can substitute back in there. And we should have it. So 100,000 times exponential function 0.06 times 70. I got 1, 2, 3, number 6, A63, A633. So 6,668,633. So that's pretty much what we have. So first we solve for the population, the function in general, with c, and after that we look for the particular condition. Initial condition to find particular solution, and that solution should not have c in it. So we just have this, and this happened to be the population. We just need to find the t after 1980. After 1980, 2050 will be equivalent to 70. And we put 70 back into t, and we have the solution. I think with that we finished a lab on chapter 4. Now we can go to chapter 5. Do you have any particular question on chapter 5? That. Right. Now we go to lab 5. This topic is linear first order differential equation. So there are 3 problems. I think I did number 3 in class. So only have left with 1 and 2. Right. First, number 1, make sure this is in the right form, the standard form of linear first order differential equation. So it is in the right form, and the form would be derivative plus some function of x I should use p of x y equal to qx. Right. I should match that with this standard form. So we say 2 is going to be p of y. P of x equal to 2. Derivative, the function, and the function of x. We can have a function of x times y as well. But anyway, we have p of x equal to 2. The next part is the integrating factor. Our integrating factor is a to the integral of px dx. That be I. A to the integral of px is 2 dx. Integral of 2 will be just 2x. So we found the integrating factor. We multiply both sides by that. So we have a to the 2x dy over dx plus 2y so put this in the box so we can see it, times a to the 2x and equal to we multiply a to the 2x on 21 as well. Right. So we do multiply both sides by a to the 2x, the integrating factor. Right. Once we multiply, we can combine this as one big product rule. Inside is a product. And no y right dy there, but should be just y. Yeah, just pretty much this term, except we write y instead of derivative. So a to the 2x times y equal to 21 a to the 2x. And next, to get rid of the integral sign, we will integrate a to the 2x times y integral of 21 a to the 2x dx, of course. Right. Still have derivative. Actually, integral. So there's no more derivative. We just have a to the 2x times y equal to integral of this 21 a to the 2x over 2 plus a constant c. And divide by a to the 2x on both sides. We should have it. Now we just have that. Now divide by a to the 2x. It's like multiply a to the negative 2x. So from here we divide a to the 2x on both sides and up with this. So that's actually a plus. So we have 21 over 2. That cancels out and that's just 21 over 2. And then that constant. e to the 2x. So that's what we have. We can also move the e to the 2x on the top, becomes c e to negative 2x. Right. So we need the equation to be in the standard form. So we find the integrating factor and we integrate, and we should have it. Right. Right. Next, I go to number 2. Let me update the list first. Right. On this review, the majority will be just differential equation, so I think I'll do a few more of this. Let's go to number 2. Sorry, kind of sloppy there. 2x. Right. Next, on this equation, if we write instead of y dy dx, we can write dy y prime, I mean. And compared to the standard form, y prime plus polynomial x y equal to, I mean, not polynomial, any function of x and any function of x. Right. Where we match these two, p of x is just 2x. Pretty much this. Right. And you integrate to find the integrating factor. Integral of 2x is e to the x squared. Integral of 2x is 2x squared over 2 would be just x squared. Right. Notice we solved earlier that the x squared, I mean e to the x squared, we do not need a constant. Did that in class. Anyway, we multiply that on both sides. Let me copy the equation. We multiply e to the x squared on both sides. So equation in the standard form, 5px, integrating factor, multiply both sides. That is x squared e to the x squared on both sides. Sorry, that is integrating factor. Right. Doesn't matter what happened, what we have on the left hand side. Once we multiply by the integrating factor, it will become just almost the first term, except for the derivative. The derivative will be for the whole thing. So once we multiply by the integrating factor, we should have just that without the derivative. Derivative is on the outside instead. So that's what we have. Right. Now we have derivative and that. Just simply integrate. We get rid of the derivative. So have e to the x squared y equal to the integral of 17x e to the x squared dx. Right. To integrate this, we'll use substitution. It will not be integration by parts, simply because e to the x squared, there's no integral for that. Right. Anyway, I will copy this from here because it might take some space. Right. Substitution. We will let u equal to x squared and we take derivative. Multiply the dx over and divide by 2x. This is the substitution that we did at the beginning of the class. So we have dx and u. Right. Substitute back into the equation. We have integral of 17x e to the u. Dx is du over 2x. So the x cancel out and the 2 outside here from the in the bottom, the 17 on the top. So we have 17 over 2. The integral e to the u du, that equal to, and that equal to 17 over 2 e to the u plus c. Right. One last step though. Ex squared times y equal to 17 over 2 e to the u, which is x squared, plus c. Now just need to divide by e to the x squared. And we just have y, that cancel out. And e to the x squared move to the top, becomes e to the negative x squared. So that is 2. I think we did number 3 in class, so we're not going to do that again. We'll go to 4 and potentially 5. Those will be the initial value problems. So when you study differential equation, there will be 2 types of differential equation. Separable equation, where we keep x and dx and y and dy separately, hence separable equations. Within that we have initial value problem. Initial value problem is kind of a differential equation, except we have the initial condition attached to it. So it can be either initial value problem for the separable equation or for linear first order differential equation. Right. Now we go to 4. By the way, we spend most of the time of the review on this differential equation. When we get to the sequence in the series, those are very simple, and we will not review the question on the finance because most of it we will cover in class. Right. So number 4 and then 5. Right, 4. If we rewrite this equation in the standard form, actually it is in the standard form. We just have the constant 1 as a coefficient. So the standard form is right. So that look like some strange thing happened in the chat, but it look right. It should be fine now. Right. Standard form derivative plus the function of x times y and another function of x. So from here we have p of x is equal to 1, and then we find integrating factors, multiply both sides. Integrating factor is e to the integral px dx. We just have 1. Integral 1 is just x, so we just e to the x. Now we multiply e to the x both sides of the equation. So we have y prime plus y equal to e to the x. We multiply e to the x on both sides. Right. So that gives us, like I said, doesn't matter what happened on the left hand side, we will have e to the x and just y. The derivative will be on the outside. E to the x times e to the x, that is the sum. I mean, we have e, and that just we add the exponents. So that 2e to the 2x, and then we just integrate to get rid of the derivative. Right. So we should have e to the xy equal to integral e to the 2x is e to the 2x over 2. The integral formula, e to the kx dx equal to e to the kx over k plus c, and k in this case is 2. Right? And plus a constant, of course. That cancel, and we have e to the x times y equal to e to the 2x plus c. Right. This problem is longer than I thought. Next, to get back to y, we divide both sides by e to the x. So that will be just y e to the 2x divided by e to the x. We have e to the 2x minus x will be just 1x, and then e to the x move to the top, we're gonna have that. Right. Of course, we're not done. That's why I wrote a line and expect more from it. Next, we have y equal to y of 0 is equal to 16. That is the initial condition. So we continue here. Y of 0 equal to 16, meaning that when x equal to 0, y is equal to 16. So we're just going to put 16 here for y. And e to the 0 plus c e to the negative 0. So e to the 0 power is 1. Negative 0 is still 0, which is still 1. So we have 16 is equal to 1 plus c. So c is equal to 15. And put 15 back in here. We have that. Right. So that part is for initial values problem. We just need to find the constant c. Overall, we still have a differential equation. We still need to integrate integrating factors and all of those steps. Right. Next, we'll go to 5. The question on the series, the sequence and series, the geometric sequence and series are not that difficult. We do a few, but most of the review here will be just for a differential equation. Right. Now we go to 5. Right. Also seems like a long problem, so I'll cut a page in half. Alright, that is derivative. And that is in the standard form. Y prime plus p of x. So a function of x times y and then another function of x on the other side. Matching this two, we have p of x is equal to x. And then we find integrating factor. By the way, as mentioned in class, this problem usually may be a little longer than I want to ask on one question. So you might have the problem with the integrating factor. You only need to find the integrating factor. Some problem you have to find everything though. So e to the integral of px dx. So have integrating factor equal to e to the integral of x dx. Integral of x will be x squared over 2. We don't need a constant as always for the integrating factor. Alright, we'll multiply this e to the x squared over 2 on both sides of that differential equation. So I multiply e to the x squared over 2 multiply to this term and x squared over 2 on that side. Next, doesn't matter what happened on what we have on the left hand side once we combine them. it is just that term where the derivative is outside. Right, I'll get rid of the derivative by integrate. Right, this one we need a substitution, so probably I will need more space, so we'll go to the next column of the page. Right, what I do is the substitution will let u equal to x squared over 2. Actually, I just copy that here. So we put u equal to x squared over 2. And we will take derivative of u. We have du over dx. Derivative. X squared derivative is 2x. 2 and 2 cancel out. Or easier, we just write 1/2 x squared, that 2x and 2 cancel out as well. Our bottom line is, that's what we have. Move the dx over, we have du equal to x dx, or du over x is dx. That is dx. Substitute in there. So we have 4x e to the, that is u, and dx will be du over x. The x cancel out. The 4 is a constant. Bring it outside. Right, integral of e to the u is still e to the u, then plus c. So that's what we have. At the end, we should have e to the x squared over 2 times y equal to 4 e to the u, which is 1/2 over x squared plus c. Divide by that on both sides. We will have y equal to, those two cancel out, we just have 4 plus c over e to the x squared over 2, or 4 plus c e to the negative 1/2 x squared. So x squared over 2 or 1/2 x squared is the same. Just have the negative there. Right. Of course, we're not done. We still have this. So when x equal to 0, y equal to 1, so 1 equal to 4 plus c e to the negative 1/2 0 square and e to the 0 power this is just e to 0 power, which is 1. So we have 1 equal to 4 plus c. So c is negative 3. And if we know c, put it back in this equation, we have, I'm sorry, not that equation. This one is, that is our solution. Go there. Sorry. So we have y equal to 4 minus 3 e to the negative 1/2 x squared. And that's what we have. So that is the initial value problem for a linear first order differential equation. Next we have geometric series and geometric sequence. We'll take a look and we'll go briefly through this and then do a couple of finance problems, and that will be it. So right now we're on the geometric sequence. Right. Because we probably seen this before, so just go over them rather quickly. Right. 6, 7, and 8. They just asked for this one. They asked for the 4th term. So in general, geometric sequence an is equal to a1 r times n minus 1. By the way, in the note we have 8. In here we have a1. Either way, it is just the first term. Whatever we have for the first term, it could be a or could be a1. It depends. But usually a1 is more standard. More people use the a1 more. So since here we find the 4th term, put form for n, a1, and r. So pretty much for those 3 problems, we use this formula for the n term in a geometric sequence. Right. Yeah, this also the same. The reason we have quite a few problems because this model, we do not have the homework, we just have the lab. That's why we have a little more per question. Right. Next we have the sum. This is the sum of the first n term of a geometric sequence. We do 13 instead of those straightforward problems. So those 2, we're going to use this formula. Again, either a1 or a, it doesn't matter. When we write that, we mean the first term. We have r to the n minus 1 over r minus 1. So like any of this problem, just need to determine what is the first term and what is the common ratio. I'm looking at number 12 now. The first term is 6. I should say the first term. You can write a1 or a is fine. The common ratio, in order to get to the next term from the previous term, we need to multiply by 2. So the common ratio, I should spell it out. And then this one want the 13 terms, the sum of the first 13 terms. So we put everything in that formula, and that's pretty much it. So we have a, the first term 6 times, by the way the ratio is -2 because the sign alternating. Oh, that's fine. -2 to n is 13 minus 1 over -2 minus 1. I'll let you simplify the problem. By the way, there's a little note here. We usually write the 13 the n term here to indicate that is the sum for the first n term. Here we know the 13, there are 13 of them, so we just go ahead and put 13 there. So that is the formula for the sum of the first n terms. Right. Number 13 is also the geometric sequence. We have the first term is 3 cents. By the way, we did something like this similar in class. Common ratio. It will be a triple on the previous day. So that will be 3 times the previous term. And we have 14 days, so n is equal to 14. And if we put everything in this formula, that formula, either A or A1 doesn't really matter. Right. So 14 terms. The first term is 0.03, and then 3 to the 14 minus 1 over 3 minus 1. Again, I'll let you do this calculation. It should be simple. Right, so that is the geometric sequence. We do not work any particular problem. Pretty much there will be 2 formulas, the n term and the sum of the first n terms. Next we have infinite geometric series. So that is the sum of infinite series. Right. 14, we'll do the same thing. There will be 7 generations, so n is equal to 7. We assume it will be 6. Anyway, not going to do that. Right. We go to 21 to 25, actually 26. All of this, we have the geometric series, infinite geometric series. The formula will be equal to the first term divided by 1 minus r. We can write infinity if we want to. Very important, the ratio has to be between -1 and 1, because if it is not, it will be undefined. If r is bigger than or equal to 1 or less than equal to -1. Right. So just take a look at 21 and 24. Then we 25 and 26. We'll take a look at that later. After that, we'll go back and do a few problem of finance application. That will be on the calculator. Right. So very straightforward. So the first term in this case is 1. The ratio to get from the first to the next is 0.7. So we have 1 minus 0.7. We have 1 over 0.3, which is 10 over 3. That's straightforward. I just multiply 10 top and bottom to get rid of the decimal. Next, to go from this term to the next, we have r is equal to 4. Since r is bigger than or equal to 1, it is undefined. So r less than 1 and less than -1, it failed. So we have the sum is undefined. Actually, we did that too. It's fine. Now, express this as decimal. I will not do 23. This looks simple enough. If we just rewrite this as 6 over 10 is 0.6, and that's 0.06, and 0.006, and so on. I think if you apply this, should be able to get it. Should be simple. I mean this. The next one I rewrite a little bit different. You have indefinite. We have 4, 5, 4, 5, 4, 5, and 4, 5, and so on. Now, focus on the first. If we can split it like this, 0.45, 0.0045, 0.123445, and then so on. As you see, because this problem has 2 digits repeating, so we have to have 2 zeros for every step. We have more. Right, once we write like that, it should be easy. This is the first term, and to go from this to the next, we need to multiply by 0.01 because decimal point move 2 place to the left. Once we have the ratio and the first term, so we have 0.45, 1 minus r, and move the decimal point 2 places to the right, top and bottom. Or if we just multiply 100 on the top and the bottom, we'll just have 45 over 99 and reduce that by 5. Sorry, by 11. We have 5 over 9 divide by 9 top and bottom, so we have 5 divided by 11. Sorry. Right. I usually want to do the application problem, so we're gonna look at 25. By the way, this is similar to a problem that I plan to do in class. So let's not do that. On this one, pendulum pop swings through an arc of 72 inches long on the first wing. So we pretty much have I can do that better with a pencil. We can have the full circle too if we need to. Anyway, let's say if swing back and forth. Initially that will be 70 inches long. Right. So the first swing, so originally kind of right. So actually that's not 70 in inches. So I think that is 70 inches. So swing an arc. I didn't say, the question didn't say it is from the middle or from the other side, but I assume it has to be from the middle. So the first one swing to an arc of 72 inches, and then the other, when it bounces back, it will not be as original point, be a little less, and that only 70% as the previous swing. So we have 0.7 of the 70 inch. So if we write out, it will be 70 for the first swing, and then 7 of the 70, and then another one we need another 0.7 of 70, and so on. So pretty much the first term is 70 and the ratio is 0.7. And now if we put this in that form, we will have the first term is 70 and pretty much that. So have 70 divided by 0.3, uh, 33.3 inches. Right. We do 25 in class, so I mean similar to it in class. Should not be a problem. Next we focus on the finance problem. Finance apps, because we indeed we just use the application on the calculator. Right. Calculator. Right. So on the calculator, sorry, wrong one. Here. When we hit the apps key, that brings in all the apps. Right. Can I put the calculator here? And we hit enter. We have the apps. We just use the first one, TVM solver. Right. Very important. Just write all the information on the first one, but then we do the second one. Right. First, and here is the number of payments. If we know that, we just go ahead and use it. If we do not know that, it will be years, the number of years, times the number of payment per year. I think the interest rate here, this is very important. This is the interest per year. Next will be easy. That's present values. The payment amount, and the future values is, of course, that's how we go by that, which is also the amount of the annuity. And this is the payment per year. or the compounding period a year. Right, so that's how to set up the prompt. Now we do the second prompt. Right, so first or actually that is the payment. On the test it will be clear what are those. We have something like this instead of just that. Right, the payment or is, this is the payment. $4,300. 6% interest. The 6% will be here. I think we just enter 6 will be just fine. Or 0.06. I think that also works. But 6. 9 years. Right, be careful with that. So we have 9 years. But this is quarterly for 9 years. So we have 9 years and 4 times a year. So that should be 36 instead. The present values, we have nothing at the moment. They ask for the amount of the annuity, which means this is the future values. We don't know what that is. We're going to put 0 for the moment. I put 0 here. And the payment per year, there will be 4 times a year. Right. Now, we can put in the calculator. Will be number of payments 9 times 4 be 36 times. Interest 6%. Present values don't have any. We make the payment of 4,300. Each payment future values leave that as 0 and 4 times a year. Very important. We are on our application. We just always keep this at the end of a period. So we keep that as 4. Alright. Now what we need to do is we go back and highlight the future values because that's what we're solving for, and hit alpha and enter, and that's what we have. So here I say if we hit alpha and enter, we have 203, 286 and 67 cents. Right, just little thing though. We see in the calculator it is negative, but usually to make things right, usually if we are making a payment, we should have the minus here. So if I go back and change that, there's minus 4,300, and here do alpha, enter again, I should get positive. So if we making a payment or we losing any money, that is the minus, but in the future we're going to gain this much after 9 years. Alright, so that most of the finance problem is about. We just need to determine what we have and what we don't. Right, just want to fill a few problems here. So next, we want the present values. The payment of 1280 are made annually, so of course, so the payment we making the payment, so what minus one time a year annually, 13 years, so that 13 times 1, so just 13 payments in total. And the present values we don't know. We're going to put 0 at the moment. Later on, that will be alpha and enter. The interest rate is 6%. Our future values we don't need to know, and annual, like meaning 1 times a year. So we just need to do that. Right. The next problem is exactly the same, but except we still find the future of the present values, everything the same, pretty much like that. They just change the term. Instead of the present values, we want the lump sum deposit today. The key here is today, which is at the present, of course. So pretty much similar to the previous one. Right. This is loan amortization. So kind of the same thing. So like if we borrow money to buy a house or a car, something like that. So it said find the payment necessary. So we do not know the payment. So we're going to have 0 here, and later on that will be alpha and n. Right. What do we have? What we have is they give us $1,000. Usually this may be like a loan or maybe a house payment, a car payment. We borrow something, but at that moment they give us the money, so we have that money at that moment. So that will be $1,000. That's the plus $1,000. Interest rate 7% annually, so once a year. Future values doesn't matter, 11 payments. Right. So we put that on the calculator. 11 payments, 7% interest rate. Right now we have $1,000 borrow for somebody. The payment leave that 0 at the moment. Our future values 0 and 1 payment a year. Right. Just need to go back to the payment and alpha, and we have negative 133.36. And this number makes sense because originally we borrow $1,000, so we have $1,000, but later on we have to make the payment, and so each payment we're going to lose this much money. Right. The next problem would be similar to that. So the finance app, we just need to figure out what we have and what we don't know. When we solve for what we don't know, we just hit alpha and then enter. Initially we put 0, but then we go back, hit alpha, enter, and we should be able to solve for it. So on the finance app we did 16, 17, and 19. Right. So this pretty much we cover what I want for test 4. Also we will not take the whole class on Wednesday. I mean on Monday. So we might have a few to have time to review at the end. So if you have any question, you can ask on Monday. This is where I want to end the video. I hope this will help you prepare for test 4. Thank you for watching.